Hello guys, before we get on with the video, this video is part of the Acing the AIME playlist which is on our page. There you can find comprehensive video guides on everything you need to know to ace the AIME. Now, let's get on with the video. Hello everyone, in today's video we'll be going through triangles and circles in the AIME and by Pi Academy, December 2024. So, chapter 1 we have some important formulas to go through, such as the law of cosines, which if we let sides BC, AC, and AB be A, B, and C respectively, let A, B, and C be A, alpha, beta, and gamma respectively. And we have a triangle here, and A squared plus B squared minus 2AB cosine gamma is equal to C squared. So this, and this angle. And gamma is the opposite angle from C. Theorem 2, law of sines, which is opposite is equal to 2 times the circumradius. Stewart's theorem, man plus dad is equal to bum plus sink. And you know which is m and which is n because B is opposite of m and C is opposite of n. Lastly, we have theorem 1.0.4, which is that in an incircle, this and this is equal because of equal tangents. Let me change color. This and this is equal, and this is equal. So these are a couple key concepts used in the AIME, which otherwise maybe would not be used in the AIME 10, 12. Starting off with problem 1. A machine shop cutting tool has the shape of a notched circle as shown. The radius of the circle is root 50 centimeters. The length of AB is 6 centimeters, and that of BC is 2 centimeters. The angle ABC is a right angle. Find the square of the distance from B to the center of the circle. So let me grab the picture real quick. Alright, so I got the graph. So let's label the graph. We have this as the origin. So let's let B be the origin. So we're going to do this with coordinate geometry. So if B is the origin, we know BC is 2. So if we let BC be the x-axis and AB be the y-axis, then we can conclude that C is 2, 0. And similarly, A is 6, 0. I mean, not 6, 0, 0, 6. So now the radius of the circle is 50 centimeters, root 50 centimeters. So we connect O to A and O to B. Keep in mind, O to B is not root 50. The angle ABC is a right angle. Find the square of the distance. So let's let O be x, y. And we have two equations. Since root 50 is the radius, we can use the distance formula on OA and OC. This gives us x minus 0 squared plus y minus 6 squared is equal to square root 50. So we get x squared plus y squared minus 12y plus 36 is equal to 50. Now doing the second equation, we get x minus 2 squared plus y minus 0 squared is equal to square root 50. And this is OC. So this gives us x squared minus 4x plus 4 plus y squared is equal to 50. Now, what we can do is we have two equations and two variables. So x squared plus y squared minus 12y is equal to 14. And x squared plus y squared minus 4x is equal to 46. So now we subtract these two, we get 46 minus 14 is equal to negative 4x plus 12y. Subtracting this, we get 32 is equal to negative 4x plus 12y. We get 8 is equal to negative x plus 3y. So we get x is equal to 3y minus 8. Now we plug this in to this equation right here. We get 3y minus 8 squared plus y squared minus 12y is equal to 14. 9y squared minus 48y plus 64 plus y squared minus 12y is equal to 14. So we get 10y squared minus 60y plus 50 is equal to 0, or y squared minus 6y plus 5 is equal to 0. Y minus 5, y minus 1. So we get x is equal to 1, y is equal to 5. And we see, is that reasonable? Or sorry. We get y is equal to 1. So we get y is equal to 1. And x is equal to negative 5. And we see, is that reasonable? It is. So the distance from B to the center of a circle is just root 26, using the distance formula. So our answer is 26. Moving on to problem 2. In the adjoining figure, two circles with radius 8 and 6 are drawn with their centers 12 units apart. At P, one of the points of intersection, a line is drawn in such a way that the chords QP and PR have equal length. Find the square of the length of QP. So what we can do is we can draw perpendiculars, like so. And we can extend the lines. We have, this is 8 and this is 6. And now we know that chords QP and PR are equal in length. So let's let this be A1 and this be A2. Let's let this be X. And, well, now we can do similar triangles. So we have X over 6 is equal to A2. Let's just be B2 and B1. A2, B2 over 18. So we know this is 3x now. So, since QP is equal to PR, A1R is equal to Y, and so A2R is equal to 3Y. So now we can do Pythagorean theorem. We have x squared plus y squared is equal to 36, and y squared plus 9x squared is equal to 64. So we can subtract, we get 8x squared is equal to 28. So x squared is equal to 7 over 2. And the question is asking us to find the square of the length of QP, which means we want to find what y is. If x squared is 7 over 2, then y squared is equal to 65 over 2, because they add to 72, and 72 over 2 is equal to 36. And we want 2y squared, so we multiply this by 4 to get 130 as our answer. Moving on to problem 3. In a circle, parallel chords of lengths 2, 3, and 4 determine central angles of alpha, beta, and alpha plus beta radians respectively, where alpha plus beta is less than pi. If cosine alpha, which is a positive rational number, is expressed as a fraction in lowest terms, what is the sum of its numerator and denominator? So, and I'm just going to use red so we can see better. So we have a circle, we have the origin here, and we have parallel chords of lengths 2, 3, and 4. So this is length 4, this is length 3, and this is length 2. And we can draw lines connecting these. So, of alpha, beta, and alpha plus beta radians. But we notice that what's cool is that we have alpha plus beta radians. So we can draw another circle. But this time we rearrange the chords. So let's draw first alpha. Obviously alpha is 2. Then we can draw beta with radians 3. And alpha and beta is radians 4. So this is cool. Now what we can do is we can do law of cosines. And what do we get with law of cosines? We get, so first of all, we want to find the circumradius. Doing law of cosines on this triangle right here, we get 2 squared is equal to r squared plus r squared minus 2r cosine alpha, which gets us 4 is equal to 2r squared, oh, this is a squared, minus 2r squared cosine alpha. And this is good because we want to find what cosine alpha is. So, now we need to find the circumradius. How are we going to find the circumradius? Well, we notice that the circumradius is equal to all the sides multiplied together over the circumradius equal to the area. And in this case, we can use triangle ABC, which we know all the side lengths of. So we have area of ABC is equal to 2 times 3 times 4 over 4r. Let me scroll down a little bit to have more space. So, what we quickly notice is that we can use Heron's to find the area. So, using Heron's formula, we get S, which is 2 plus 3 plus 4, which is 9 over 2. 9 over 2 times 5 over 2 times 3 over 2 and times 1 over 2. So this is Heron's formula. We get, taking stuff out, we get this root 15. So we have 3 over 4 root 15 is equal to 2 times 3 times 4, which we can cross out and just write 24 over 4r, which means 3 root 15 is equal to 24 over r. So r is equal to 8 over root 15. Now that we found what r is, we can plug it back into this equation. So we get 4 is equal to 128 over 15 minus 128 over 15 cosine alpha. We multiply 15 on both sides. 60 is equal to 128 minus 128 cosine alpha. Subtracting 128 on both sides, we get negative 68 is equal to negative 128 cosine alpha. So we get final answer 68 over 128. Dividing by 4, we get 17 over 32 as our answer. So 49. Problem 4, 1986 AIME 9. In ABC, AB is 425, BC is 450, and AC is 510. An interior point P is then drawn, and segments are drawn through P parallel to the sides of the triangle. If these 3 segments are of an equal length D, find D. So we first label A, B, and C. This is 425. This is 450. This is 510. And let's say this point here is P. So we know these three segments are of length D. So what we can do is, so we can do similar triangles. BE over 450 is equal to D over 510. So D is equal to 15 over 17D. Sorry, not D. BE is equal to 15 over 17D. And for visualization purposes, this triangle is similar to the big triangle. We can do the same for EC. We have EC over 450 is equal to D over 425. So EC is equal to 18 over 17D. Now if you notice, EC plus BE is equal to 450 plus E prime. So BC minus E prime is equal to D prime F. And we notice this because if we move this length to here, parallelogram this into here, we notice that we're missing a small sliver. So we get 450 minus E prime is equal to D. But we know E prime is EC plus BE prime minus 450. So we get 450 minus 33 over 17 D plus 450 now is equal to D. So 50 D over 17 is equal to 900. So we get D is equal to 306. Problem 5. Let P be an interior point of the triangle ABC and extend lines from vertices through P to the opposite sides. Let ABCD denote the lengths of segments included in the figure. Find the product ABC if A plus B plus C is 43 and D is 3. Alright, so this is an areas problem. What we can do is, first of all, PBC to the big triangle. And the ratio of this area, since they have the same base, is D over A plus D. Doing the same for the rest, we get D is equal to PAC But wait, we notice PBC plus PAC plus PAB is ABC. So we add all these up. We know D is 3. So we plug that in. Now we expand. So we factor out a 3, and we get BC plus 3B plus 3C plus 9 plus AB plus A plus 3A plus 3B plus 9 plus AC plus 3A plus 3C plus 9. So what this is going to give us is, this is equal to ABC plus 3AB plus BC plus AC plus 9A plus B plus C plus 27. So now we cancel out. So first of all, we can cancel out A 27, which gets us, so hold on, 3 times AB plus BC plus AC. Just cleaning up the other side, this is what we get. These two obviously cross out. This crosses out, and this leaves 9a plus 9a, 9b plus 9c, and this crosses out. So we get 9a plus 9b plus 9c plus 54 is equal to ABC. And we can erase the rest. So 9a plus 9b plus 9c is 43. So 9 times 43 plus 54 is our answer, which is 441. Now we move on to problem 6. So 1992, AIME 9. Trapezoid ABCD has sides AB is equal to 92, BC is equal to 50, CD is 19, and AD is 70, with AB is parallel to CD. A circle with center P on AB is drawn tangent to BC and AD. Given that AP is M over N, find M plus N. A key thing with trapezoids is that a lot of times you get similar triangles when you extend them. So let's extend the lines and make them meet at point E. Something like this, where these are the tangency points. So we let this part be x, and this part be 92 minus x. We know BC is 50, AD is 70, and DC is 19. So what we can do is we draw 90-degree angles, and this is an angle bisector. So using angle bisector theorem, x over 92 minus x is equal to 70 plus ED over 50 plus EC. And we also know that EDC is similar to ADB, so we have ED over ED plus 70 is equal to 19 over 92 is equal to EC over EC plus 50. So now we solve. 92 ED is equal to 19 ED plus 19 times 70. Now we get ED, so the 133 over 73. Doing the same for EC, we get EC is equal to 950 or 73. Now we plug both of these into this equation. X times 50 plus 950. X plus 50 is equal to 92 minus x times 70 plus 1330. And now finishing this equation, we get x is equal to 161 over 3, which is 164. Thank you guys for watching. Today we went through 6 pretty hard AIME problems that will help you prepare for JMO or for the MC12. Thank you for watching, everyone, and more videos will be coming soon, and I will link this handout in the description.